Welcome to the online platform Education Unlimited. In this presentation, we'll be looking at the math topic of algebra, where we will zoom in on factorization. At any time during this presentation, you may like, share, and subscribe. I hope that you will enjoy this presentation. As we look at factorization, the first step is to define factorization. And so factorization is the process of factoring polynomials whose products equals to give a polynomial. Example, 3x plus 12 is equal to 3 bracket x plus 4, so that 3x plus 12 is a product and 3 and x plus 4 are factors, just as how 12 is a product and 3 and 4 are factors. Hence, we factorize. As we look at this slide, I must first of all give a disclaimer that this part of the presentation is not the original work of Education Unlimited, but it was retrieved from the internet and is being used now for educational purposes. And so the previous slide talked about polynomials. Let us now define what's a polynomial. The website mathworld.com defines a polynomial as a mathematical expression involving a sum of powers in one or more variables multiplied by coefficients. And so the chart here will give a clearer understanding of polynomial. It looks at the types of polynomial and the number of terms. And so following the cursor, monomials mean one term, looking at the prefix mono. And so examples are 6, 4x cubed, negative 5a squared b cubed. And binomials mean two terms. For example, 6x plus 2 or y plus 2f. And trinomials, looking at the prefix tri, mean three terms. For example, 3x squared minus 5x plus 8. Even though it is a quadratic equation, it is a trinomial. And then the broad setting, polynomials, the prefix poly meaning many. So polynomials mean many terms. And an example is 2x cubed minus 6x squared minus 5x plus 8. We can take it a step further by looking at the types of polynomial according to their degree. And so the constant polynomial has a degree of 0. We look at 8. Anything raised to the 0 power is 1. So 8 is a polynomial of 0 degrees. 8, for example, multiplied by x to the 0 power, while x to the 0 power is 1. So 8 multiplied by 1 is 8. So the constant polynomial has a degree of 0. Then we look at linear polynomials, which has a degree of 1. So x plus 8 has a degree of 1 because x to the first power is x. So x plus 8 is a linear polynomial of degree 1. Then we look at a quadratic polynomial which has a degree of 2. For example, 3x squared minus 2x plus 7, where x squared is a degree of 2. And then we look at a cubic polynomial which has a degree of 3. For example, 5x cubed as a degree of 3 because x is risen to the third power. As we look at factorization, let us look now at factoring out by using the greatest common factor. Looking at this example, which reads 6x squared t plus 8xt minus 12t, the greatest common factor there being 2t. Why 2t? 2t is the only variable that all three can be divided by, because if we had used 6t could not have been a factor for 6t or 8t and 12t. So for example, while 6t could be a factor for 6t and 12t, it could not be a factor for 8t. So the greatest common factor here is 2t. The key is to find a variable that all three can be divided by. So we pull 2t outside of the bracket and then we divide. For example, 2 into 6 gives us 3, and we put back the x squared because we already have 2t. So if we were supposed to multiply 2t by 3x squared, the result would be 6x squared t. And then 2t into 8xt gives us 4x. So if we test, 2 multiplied by 4 would give us 8, and t multiplied by x would also give us 8xt. And then 2 into 12 gives us 6. The t is already there, and so if we were supposed to multiply, we would get an answer of 2t times negative 6 would give us negative 12t. And so we pull or utilize the greatest common factor in this example, which would be 2t. Another type of factorization is factoring by grouping. Factoring by grouping. In algebra, we normally group like terms. So as we look at this expression, which reads mn squared plus 7m plus 3n squared plus 21. So we will group the like terms. It is already in a grouped format, so all we do is to bracket mn squared plus 7m bracket plus 3n squared plus 21 bracket. And so for the first bracket, what is common is m. So we put m outside of the bracket and we divide. M into mn squared gives us n squared. M into 7m gives us 7. So if we are supposed to test, we multiply m by n squared to get mn squared and m by 7 to get 7m. And then I normally say, while I teach, anything, while you're factoring here, anything that's in the bracket on this side, for it to be correct, it should also be in the bracket on this side. But let us test. So we have 3 that is common. 3 is the common factor here because 3 multiplied by n squared gives us 3n squared, and 21 divided by 3 gives us 7. So n squared plus 7 is in this bracket, and n squared plus 7 is in this bracket too. So while we factorize, the next step would be m plus 3, all bracketed, open bracket, n squared plus 7. So here we factorize by grouping. So looking at another example of factoring by grouping, looking at this expression that reads 2y squared plus az minus 2z minus ay squared. And that, just to note, in some jurisdiction, this is pronounced z. In some jurisdiction, it's pronounced z. But I'll use z for now. So 2y squared minus, sorry, 2y squared plus az minus 2z minus ay squared. The first thing that we will do is to rearrange the expression so that it is easier to factorize. So while we have 2y squared here, we also have a minus 2z here. So we rearrange by grouping these two together. And then minus ay squared must be rearranged and grouped beside plus az. And so 2 is a common factor of this part of the expression. And so we put 2 outside the brackets. So we divide 2 into 2y squared gives us y squared. 2 into minus 2z gives us minus z. Again, anything that's in this bracket, for the factorization to be correct, it must also be in this bracket. And so we also see that a common factor here in this part of the expression is a. So we pull now minus ay squared divided by minus a gives us y squared, and az divided by minus a gives us minus z, because if we test, negative a times y squared gives us negative a squared, and negative a multiplied by negative z which gives us a positive. Two negatives, a negative multiplied by a negative or a negative divided by a negative gives us a resulting positive. And so while y squared minus z is in this bracket, it must also be y squared minus z in this bracket. And so to factorize, we say 2 minus a in one bracket and y squared minus z in the other bracket. So we have factorized this equation by factoring by grouping. A little bit technical, but if we apply the same principles here, then it will all be made easy. As we continue factorization, we now look at factoring trinomials. The expression here that reads ax squared plus bx plus c is a quadratic expression, rather, and is also a trinomial. I have placed this here because in factoring this trinomial, we'll be using the AC method, where in this format of a quadratic equation, A or 4 represents A, and 11 represents B, and 6 represents C. And so in factoring this expression, 4y squared minus 11y plus 6, we multiply a by c, which is 4 multiplied by 6. 4 multiplied by 6 gives us an answer of 24. And then we pull all the factors of 24. Let us go by looking at the cursor. 4 multiplied by 6 is 24. 2 multiplied by 12 is 24. 3 multiplied by 8 is 24. And 24 multiplied by 1 gives us 24. But which two factors of 24, when we add, we will get the middle term of minus 11. So those two factors would be 3 and 8. So that minus 8 minus 3 would give us an answer of minus or negative 11. And so we write 4y squared minus 8y minus 3y plus 6. But why did we write it like this? We wrote it like this because it is easier to factorize because 4 is a factor of 4 and 4 is a factor of 8. 3 right here is a factor of 3 and 3 is a factor of 6. And so we divide. 4y squared divided by 4y gives us y, and minus 8y divided by 4y gives us minus 2. So anything that's in this bracket here must also be in this bracket here for this expression to be properly factorized. So for this side, minus 3y divided by minus 3 gives us y, and positive 6 divided by minus 3 gives us negative 2, so that a positive number divided by a negative number gives us a negative number. So the two factors here that we have is, looking at the cursor, 4y minus 3 in one bracket and y minus 2 in the other bracket. So 4y minus 3 is a factor of this expression here, and y minus 2 is also a factor. So these are two factors. So we have factorized this expression. As we continue factoring trinomials, let us look at this expression that reads 16y cubed plus 24y squared minus 16y. The key, first of all, to solving this type of trinomial is to factor out the greatest common factor. So the greatest common factor here being 8y, because 16y cubed and 24y squared and minus 16y can all be divided by 8y without getting a remainder. Also, 8y is the highest or greatest common factor of all three. And so we divide 16y cubed by 8y gives us 2y squared. Let us quickly look at this by pulling the pen to divide 16. This is the simplest way that we could look at it. Times y multiply by y multiply by y divided by 8y. So 16 divided by 8 gives us 2. Let us put the 2 here. And then this y cancel this y, so that the answer would now be 2y squared. This is one way that we can arrive at the answer. We can also use the power of indices, in that when we multiply indices, we would add the powers. And when we divide indices, we would subtract the power, so that it would read 16. Then we put y cube minus 1, because the 8y, the y is to the first power. So 8 into 16 gives us 2. And then y cube is to the third power. And this y here to the first power. So 3 minus 1 would give us an answer now. We put back the 2. And we put back the y, and we put back the square. So these are two ways that we can look at it, but that's all in another topic. So I was just briefly looking at it for the class tonight, for our online class. So let me get these out as we continue to divide this expression by 8y. So we continue to divide this expression by 8y. Let us pull back the cursor. So we're now at 24y squared divided by 8y. 8 into 24 gives us 3, and y into y squared would give us y. Then minus 16y divided by 8y, the negative sign must stand here. So 8 into 16 gives us 2, and y into y is cancelled. So that the new expression would read 8y bracket 2y squared plus 3y minus 2. This part of the expression is a quadratic. And so we can utilize the AC method that we learned in the previous slide to factorize this part of the expression. So we multiply A, which is 2, by C, which is also 2. 2 multiplied by 2 is 4. Then we say, which two factors of 4, we highlighted them, when we add them or subtract for that matter, the result would give us the middle term of 3. So it is 4 and 1. Also, we could have used 1 and 2, but 1 and 2 would not have factorized the expression. So we use 1 and 4. Why we use 1 and 4? 4y minus 1y or minus y gives us 3. So we write 8y, 2y squared plus 3y minus 2, which is this part of the expression. We bring it a step further. 8y, open bracket, 2y squared, 4y minus y, which is actually 1y, but we do not say 1y or 1x in maths. So 4y minus y gives us 3y, and we put back the minus 2. Now we're going to factorize, so we use bracket and parentheses. So the common factor here being 2y, because 2y, for this part of the expression, 2y is common, is a common factor, is the highest common factor. 2y into 2y squared gives us y, and 2y into plus 4y gives us 2. Okay, anything that's in this bracket here must also be in this bracket here. So we divide negative y by y to get negative 1. Then we divide negative 2 by positive 2 to get negative 1 here. Okay? And then the two factors now would be 2y minus 1, and the other factor would be y plus 2. And then we have a third factor coming down the line, which was 8y. So now we had factorized this one completely. For those students in the Caribbean Examination Council normally puts this question as to factorize completely, so that if we had factorized up to here, it would not have been factorized completely unless this part could not be factorized, but this part can be factorized, so we factorize it completely to get an answer of 8y bracket 2y minus 1 bracket y plus 2. So this expression of 16y cubed plus 24y squared minus 16y has 3 factors. This was quite a challenging one, but following the same steps, the same procedures, then we will arrive at the answer. As we continue factorization, now let's look at factoring perfect square trinomials. We utilize the formats in purple on this side to read x squared plus 2xy plus y squared is equal to x plus y, or open bracket x plus y close bracket all squared, or we can utilize x squared minus 2xy plus y squared to equal to open bracket x minus y close bracket all squared. In looking at this expression here, we will utilize, it looks familiar, it looks relative, it looks related to this format. So this format is related to this expression where x would represent the 16p. So the square root of 16p squared would be 4p. And the square root of 25q squared would be 5q. So that the square root of 25 is 5 and the square root of q squared is q. So that 5q represents y and 4p represents x, and we put back the minus 2. So factoring it completely, 4p represents x, follow the cursor, and 5q represents y, so it would read open bracket 4p minus 5q close bracket all squared. We now had factored a perfect square trinomial. Quite easy. If we were supposed to multiply or expand this part of the expression, it would result in this part of the expression, but we wanted to factorize it, so the answer is open bracket 4p minus 5q close bracket all squared. Quite easy once we apply the formats on this side of the slide. As we continue, as we continue to factor using perfect square trinomials, let us look at this expression here that reads 36x squared y squared plus 84xy plus 49. We can factor this by looking at the first format here, where the square root of 36 x squared y squared must be 6xy. Square root of 36 being 6, square root of x squared being x, and the square root of y squared being y. So 6xy represents x. And then on this side, the square root of 49 is 7. So 7 representing the y. So we pull in from this format, we would now read open bracket 6xy close bracket all squared plus 2 open bracket 6xy close bracket because 6xy represents x, and open bracket close 7 close bracket because 7 represents y. So to factorize this completely using this first format here in purple, we would now have 6xy open bracket 6xy plus 7 close bracket all squared. Quite simple again. Once we apply, employ, or for that matter, utilize the formats. Easy formats to remember. X squared plus 2xy plus y squared is equal to open bracket x plus y close bracket all square, or we use another format, x squared minus 2xy plus y squared is equal to open bracket x minus y close bracket all square. Depending on the expression, we can apply whichever of the formats applies to the expression that is given to us. Quite simple as we move along, enjoying the class tonight. Remember, at any time you can like, you can share, and you can subscribe to this channel, Education Unlimited, as we continue to have fun, as we continue to appreciate the goodness and the uniqueness of this subject called math. Quite an easy question. Before we close this presentation, let's go a little bit further. Let's look at some extra. We're getting some extra here in this presentation. So on this side, as we factor binomials, on this side we have three formats. The first one reads x squared minus y squared is equal to open bracket x plus y close bracket open bracket x minus y. On this side here, we see that's the difference of squares. where the minus sign signifies or show that it's the difference of square. And then this one reads x cubed minus y cubed is equal to open bracket x minus y close bracket open bracket x squared plus xy plus y squared close bracket. This is the difference of cubes, the difference of cubes. And then the third format reads x cubed plus y cubed is equal to open bracket x plus y close bracket open bracket x squared minus xy plus y squared close bracket. This is the sum of cubes, so that x squared minus y squared, that is the difference of squared, because x to the second power is squared and y to the second power is squared, so that x to the third power is cube and y to the third power is cube. So this format here is the difference of cubes, and this format here is the sum of cubes. Quite easy once we can utilize these formats as we go along in this presentation. Remember now, you can like these videos, you can share these videos with your friends, with your families, with anyone. You can subscribe to this channel, the online platform called Education Unlimited, as we appreciate, as we enjoy, as we have fun learning again this unique subject, quite a unique subject called math. Looking at factoring difference of squares, this is the last part of our presentation. The factoring difference of squares, this for those students in the Caribbean, this is a popular question that the CXC puts on its examinations, the difference of squares. This expression reads, it's actually an equation because I solved this part showing working, but this is what we're looking at. Looking at the cursor, this is what we're looking at. So it's an expression. All right, so it reads 16 squared minus 4. If we were asked to factor or factorize this, the first thing that we would do is to find the square root of 16x squared. The square root of 16x squared must be 4x. Okay, must be 4x. And the square root of 4 must be 2, and the minus sign right here. So that to factor this square, quite easy, it would be 4x plus 2. So anything that's on one side, I normally say must be on the other side. But in this type of factoring or factorization, because the minus sign or negative sign is here, then the sign here must be a plus and this one must be a minus, because plus times a minus gives us a minus. So the variables are the same, 4x and 2, 4x and 2, but because it's a difference of squares, the sign would be different for each factor. One must be 4x plus 2 and the other must be 4x minus 2. So remember now, because multiplication is commutative, we could have put the 4x minus 2 on this side and the 4x plus 2 on that side. But in maths, the principle is to put the plus side first. So it would read 4x plus 2, open bracket, 4x plus 2, close bracket, open bracket, 4x minus 2. Quite simple. This is a very simple maths once we apply this format using the square root here. Before we close this presentation, let's look at some takeaways from this class. We looked at polynomials, defining polynomials, and looking at the type of polynomials and looking at the degrees of polynomials. We then look at the different ways of factoring or factorization. One, we pull the greatest common factor. Then we factorize by grouping, and we factor the number of trinomials. And then we look at the format in factoring perfect squares and factoring difference of squares. Quite an interesting presentation. I hope that you enjoyed this class. I hope that you will replay the presentation. I also hope that you will like the presentation to support the channel as we go along. You will share the presentation again to support the channel as we go along, and you will subscribe to the channel to support the channel as we go along, to show that you enjoy, to show that you appreciate what we are doing, and that you are in this thing together as a part of the community, as a part of the online platform. Our next topic in algebra, we would look at any one of these three: expansion, algebraic equations, subject of the formula. These are the topics remaining for algebra. So remember to look out, those who subscribe, for your notification, and those who did not or have not subscribed as yet, you too can check the channel to look out for these interesting videos that will be presented in the future. Thank you very much.